Hi class, this video is going to help with 8.1, and this is the start of our hypothesis testing. So the section kind of has a lot in it, but we will do the same kind of stuff in the next couple sections as well in a little more detail. But 8.1 is the start of our hypothesis testing. So what is um, hypothesis testing? What is a hypothesis? A hypothesis in statistics is a claim or a statement about a population, a property. So the property could be a proportion or a mean. Those are the two that we're going to work with. It could be a standard deviation as well, but that one's a little bit harder, and we're not doing it in this class. So we will still look at the same two things we've been looking at. Is like our proportion is, oh, there's 50 people out of 200 that whatever our claim is, it will have something like that, or it could give you it in a percent as well. So um, the hypothesis is something about that. It's a claim that somebody has, and the test is a procedure for testing whether this claim is true for the full population. So overall idea, I have an idea like this is perfect one for right now. Um, how many people are dying from COVID? So if the government or the CDC or whoever claims there's 3% of the population dying from COVID, or 4%, or whatever they want to say, we'll just stick with 3. Um, then we take our data of a sample like maybe Wyoming, and we compare our sample to whether or not that's true for the 3%. And then we use statistics to say whether it's true or not, all based on probability. Okay, so we have the sample. Hopefully you collected that sample well. Okay, that's an issue, huge issue. Then we take this sample and we do some data and we compare it, and we just say everything's like this. It's either 3% or it's not. So that's the overall idea. So my claim, an example of the claim is exactly what I just said. 3% of Americans have died from the coronavirus. That's a claim. So those are the kind of things you're going to see. So we're going to learn methods to test this type of claim. Okay, and we start with two types of hypotheses. Of hypothesis. So we have the null hypothesis. So this is denoted by HO when we write it out, which you'll see more of in a second, is a statement that the value of the population parameter, that is the mean, the proportion, or the standard deviation, is equal to some claimed value. So basically we're saying either P equals some value or the mean equals some value. So either the portion or the mean equals some value. That's what the null says. It equals this. So in our claim, we would have said that the proportion P equals 0.03 for our claim of 3%. The alternative hypothesis depends on kind of what you want to test. Either you want to test it doesn't equal. So you'd equal, doesn't equal. Like that's all I'm saying. So it just doesn't equal 3%. Or maybe we want to say it's less than 3%. Okay, or maybe we want to claim it's greater than 3%. So our alternative hypothesis is denoted with HA, the most common, sometimes H1. I did find that your book in the notes and stuff used H1. I don't know. I always see it HA. I always write it HA. So is a statement that the parameter has a value that somehow differs from the null. So this is your statement that is different from that null hypothesis. So it'll have these symbols. So the null will have equal, and the alternative has the other one. Is it less than? Is it greater than? Is it just not equal to? All right, so we're going to practice writing this hypothesis because that's important. Like that's a 90% of your homework, as a matter of fact. So let's look at this first example. Most adults would erase all of their personal information online if they could. A GIS software surveys of 600 randomly selected adults shows that 59% of them would erase all of their personal information. State the null and an alternative hypothesis. I put a little note here. When I say most adults, we think about above and below 50%. So that's a little tricky, and that's why we're doing this one. So I would state this as HO, that's my null hypothesis, is equal to, so my next symbol is either a P for proportion or the fancy U, it's called a mu, for mean of my sample, because that's our samples information. So we would say P is equal, always equal to the 0.5, because we want to know if most adults, so are we above or are we below 0.5? So the alternative hypothesis is going to be that you are greater than 0.5. Most adults would erase this. Randomly selected, erase all their information, state the null. Most, so I think we want to show, typically it's a little better with showing like it says great, you want it greater. This one's kind of hard to tell if it would be greater or less or not equal, but they want to show that most people want to do this. So they want to say that greater than 0.5. Does that make sense? Like I'm saying most adults, like it has to be greater. I'm not saying like at least, or I'm not saying it like it's we want it less than. So these are my hypothesis testing, or not testing, my hypothesis claims. And then what we'll do, which we're not doing in this section completely, sort of, but we're going to then put it into StatCrunch or into a formula, and we're going to use the sample of 0.59, and we're going to decide whether that's good enough that we can say that you're greater than 0.5, or we will say no, you equal 0.5. So we're either going to say this one, we have evidence for this one, or we have evidence for this one. That's how we say it. We don't say for sure. Going back to, we are never going to say anything's for sure. We're always going to say we have evidence to support. Okay. All right, so let's do another one. This one I thought was a little easier. So fewer than 95% of the adults have a cell phone. In this Marias poll, whatever that is, of 1,159 adults, 87% said they have a cell phone. What's our null? What's our alternative? So our null, we would again state with a 0. And is this talking about a percent or like a proportion of people, percents and proportions, right? If I divide my proportion, I get a percent. So, or is this giving us a mean? Definitely a proportion. So what would we say? P equals, what are we claiming? We're claiming 95%. Our alternative idea is claiming what? If you're saying fewer than 95%, what are you claiming? You're less than 0.95. And then you could see the 87%. So we're trying to decide, is this 87% enough for me to say, yeah, it's less than? Or is there enough evidence, or is there not enough evidence and I have to say, nope, we're staying at the 95? Okay, see how that kind of works? Like, is this evidence going to show me enough of a change that I can actually say it? Okay, number 3. The mean pulse rate of adult males is equal to 69 BPMs. For the random sample of 153 adult males, the mean pulse rate is this, and the standard deviation is this. So what would be my null? Well, first of all, am I going to use a P for proportion or a weird looking U for mean? I need the U. Everything says mean. And it always equals, always. So what does the claim say for equals? Equal to 69. Okay, what's our alternative on this one? The mean pulse rate of a males equals this. For a random sample, does it see how it doesn't say fewer or more or most? Then that means it does not equal 69. Like we aren't saying it's greater. We're not saying it's less. We're just saying, no, you're wrong. It's not 69. Okay. So then we would have to take this data, right? We're only really using this data here, but we take this data, compare it, do some math, and decide whether or not it's enough evidence to be different from 69 as our mean. Okay. So, oh, and then I just put the little solutions on there just for those of you that are from home. So then we move on to something called a significant level. So we want to know, how accurate would you like me to be? Do you want to say that I can either go with that null or that alternative, right? I could have enough evidence for one or the other at the level of 99%, 95%? Do you want me to be at weird one like 96%? So that level of probability. 99 would be like, I want to be really accurate, or 95, like, it's close enough, right? Or 90 even, maybe, that's good enough. So that significant level is important, and we use StatCrunch in our normal and our T calculators that we've already done to find my significant level. Okay, so we use StatCrunch. All right, so we do have to be careful in StatCrunch. If it's not equal, I thought I had a little picture of that. I do. Then we call it a two-tailed test, so it's going to be a little bit different, and I guess I'll go over that when we hit the little pictures a little more. But just be careful if you need to click that between button if you are a equal and not equal on your hypothesis, because you're saying it's two-tailed. It has ends on both sides. So you have you're either higher or lower. We don't know. We're looking at that, right? If you're just saying you're less than or just greater than, then you're either right or left-tailed test. And so you have to put in the greater than or less than in StatCrunch. No, you always do the between for the critical value. You will for the second part, though. For the critical value, always do the between. Yeah, always. Okay. I was confusing my two things. I just need to go in order. I'm like, wait, you only change it. We'll show you in StatCrunch in a minute. So significant level, we've been finding. You can write down your general ones as well. We have some in our other notes for the T, and that's our mean, and or the Z. Okay, so these are the test statistics. This is our proportion and our means. We're not going to do the standard deviation. It's chi-squared. It's not that hard. It's not like this big trick. We don't have enough time, and this is an intro to stats. So that's just something we don't get to. And another one we don't really get to is, well, if the standard deviation is known of our population. Very rare right here. Okay, that's not the world we're living in. It's super rare. The world we're living in is right here with the T or the Z. But I wanted to show you there are other things, and these are our formulas. Okay, this is how we get what we call our test statistic. We can also find these on StatCrunch. Okay, and that's going to bring us to our critical region, which is our rejection region. So our basically, if I let's see, it says if is the area corresponding to all the values of the test statistic that cause us to reject the null. So if we're in those like way up high or on the in between, if we're in those critical regions, those are our rejection regions. Okay, and let me show you some pictures. And it depends on what your original thing looks like. But these are the three types of tests that we would have. We're going to have a two-tailed test where you have a section here and a section here, and these are the rejection regions. Okay, that's on our two-tailed. Our left-tailed, these just didn't show very good. This should be like darkened over here on the left, and the right is darkened on the right. So that's helpful, right? Right? The right's on the right, the left's on the left. And that's your rejection region here as well, or here as well. Okay, so those are like your rejection regions. What does that mean? It means you reject the null, and you're now going to go with the claim that it was less than or greater than or not equal to. Like you are saying that claim is correct based on this data. So you reject the null when you reject something. It's in our notes too. So this method right here, we can use our test statistic with our Z or our T for the 95, 99%, and we can see if it's in that rejection region. That is a method. It is the critical value method is what they call that. The other method is the p-value method. So p-values are easier, kind of. I kind of find them easier. So this is the hypothesis test. The p-value is the probability of getting a value of a test statistic that is at least as extreme as the blah, 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 blah. And we find it basically, are you in this region, or these regions? Based on probability, you can just find this P, this probability on StatCrunch. So I can take a critical value and my Z or my T and decide if it's above or below. Or I can find the probability that's above or below. So they're the same kind of idea. Hold on, I'm gonna sneeze. Woo! I think I'm gonna sneeze again. All right. So once I get to some problems, this will hopefully make a little more sense. Here's a little chart to kind of help you with that. I just liked it, so I put it on your notes. Okay. So the decision, if the p-value is less than your critical value, you reject. So I like to say it, if the p is low, the null must go. It rhymes, it's cool. So if the p is low, the null must go. I like using the p-value. This is what I'm going to focus on. This is what I'm going to show you a lot. Why am I talking about the critical value method? Because we actually have to use it in one of ours, and it really is good to know there are two ways, and the critical value method is supposedly more accurate. I mean, all of these are a guess, everything. What could mess up your whole thing? You didn't do a good sample. Okay, hold on. I'm going to blow my nose without you listening. Okay, I've been sick, so I'm afraid to go anywhere. It's fine. You're allowed to be sick occasionally. All right, so if our P is low, the null must go. So we're basically saying we have evidence for the alternative hypothesis. If your P is high, you're going to fail to reject. What does it mean to fail to reject? It means I'm basically accepting it, but I don't want to say that because it's still a probability. It's still like a guess. So I'm saying I have the evidence to go with the null, to stay with that original claim. So here's some help with the wording. Critical values. So this is the same thing I was talking about. You compare your test statistics to your critical value. I mean, it's the same idea. Is your test statistic greater than your critical value? Yes or no? You either reject or you don't reject that null hypothesis. And that is exactly how I always say it. I either reject the null or I fail to reject the null. Those are my options, one or the other. Okay, so what if I make a mistake? And I'm going to have to look up, there's this cool thing, now I can't think of it, but it's all right. So what if I make a mistake? So there's two types of mistakes. Type 1 error is the mistake of I rejected the null when it was actually true. Whoops. So the symbol alpha, it stands for representing the probability of a type 1 error. Okay, so type 1 error. So type 1 error equals rejecting the null when the null is true. So this might be like helpful for a little cheat sheet for the next exam. So type 2 error is the mistake of failing to reject the null when it actually is false. So they use a beta. So we failed to reject the null when it really was false. I did have enough evidence for that alternative. Oops. So consider the claim that medical procedure is designed to increase the likelihood of a baby girl. So you want to have a baby girl and you have a medical procedure that's designed to increase the likelihood of having a baby girl. So that the probability of a baby girl is greater than half. Given the following null and alternative hypothesis, write a statement describing a type 1 or type 2 error. So what would be our type 1 error in this? So we would reject the null, and the null would be that you equal the 0.5, right? Equal 0.5, and where we would reject it when it's actually true. So I would be saying, I was reading what I thought was my answer key, and it is not the answer key to this question. So I would be saying, I like that I say solution. Oh, I do have it on here. So I would be saying that because we are rejecting the null when it is true. So I would say this isn't true, and you would conclude that you are greater than 0.5. So you're saying that medicine works when in reality there's no effect. Okay? So you would be saying, "Oh yeah, that medicine works." Oh no, it doesn't. A type 2 error for the same one would be where you fail to reject that alternative hypothesis when really it is false. So what would we be doing? We would be saying, all right, then you are greater than 0.5. So yay, that medicine's working or whatever it is that causes you to have a girl stand on your head. But we fail to support that conclusion. In this type, the metal we say it doesn't have effect, but really it does. So we're saying, oh, that medicine didn't work, but really the evidence is it really did work. Okay, so those are the two types of errors. So you might have to pick like problems like just like this, where you're given the hypothesis, null and alternative, and you have to say what would be the error. That's the kind of questions you'll see with that. I liked this little chart that helps with hypothesis testing. Now, we're not doing full hypothesis testing yet. We're preparing with like a ton of detail, but we aren't quite there yet. So our next section will obviously be that. Okay, so here is a help with, okay, so first you have the claim and you write your hypothesis testing, right? Then you find your significant level, like what level do you want to be at? And then you identify your test statistic and you either do the p-value method or the critical value, and then you restate your decision. Am I going to reject the null or accept the null? Okay, so I have some problems to try with you, and we are definitely going to need to open up our StatCrunch. I have something in my eye. So a friend is tested to see whether he can tell bottled water from tap water. There are 90 trials, half of the bottled water, half with bottled water and half with tap water, and he gets 54 right. So what is the null hypothesis for this one? So we would say HO. And is this a P or a mean? Are we having like so many out of so many or a percent? Yes, so we have a P. And we would say then it equals the half. And our alternative, what are we claiming, is that, to see whether he can tell bottom or that he is, so we're saying he wants to be greater than 0.5. Like he is saying, yeah, I can tell the difference. So definitely bigger than 0.5. Do you see how to read that out? Like I had to think about it. He wants to prove he is greater, like that he can tell the difference. Okay. Number 2 is just a hypothesis testing. I thought I had one where I used StatCrunch because we've already done one like 2 and 3. You can try those. 4. 4 is the first one. Okay. So 4 says, so I'm going to kind of skip 2 and 3. You're please write them out. This one should be a less than, write that down, and a not equal. Equal and not equal. Null's always equal. So see if you can write those out. Claim. Most adults would erase all of their personal information online if they could. So 824 randomly selected adults showed that 54% of them would erase all their data online if they could. What is the value of the test statistic? Okay, so what is the value of the test statistic? So give me a sec. And we're going to go to StatCrunch, which I should have had open, but I didn't. Thought I had it up here somewhere. Yeah, StatCrunch. I don't remember if it's logged in. I'm going to show you where to get this test statistic. So we can use the formula, which I am going to show you in just a sec. Open StatCrunch, but I want to show you in StatCrunch. So what do we have? A proportion or a mean? When we said 824 and 54% of them. We have a proportion. I'm going to do this. Oops. And whoopoo. Maybe it'll make it go a little bit bigger. So what I want to do for this is I'm thinking 54%, right? So when I go to stat and I go to proportion, which I've done before to get the confidence interval, I'm going to go to one sample with summary. So where did I go? I had a proportion. So I go to proportion, one sample with summary, and I have to know the number of successes in my sample. And it just told me that 0.54. So I have to find that by 0.54 times 824. So 0.54, get out my calculator, times 824 is going to give me 444.96 out of 824. So I got to put in my 444.96. Yes, do the decimals. If you do 445, it just is a little bit off and it may count it wrong in MyMathLab. I think it'll be close enough, but I still just want to be careful. So 824 here. Hypothesis testis. What was our claim is that most adults, so we want to keep the 0.5 and then we want to say is greater because we wanted to know if it's greater than 0.5 and we compute and looky here, we have our Z test statistic right here and we have our p-value. Now, is that p-value greater than or less than our critical value? We weren't given one. We're just asked the test statistic. But we could look at that and know, is it greater than 0.05? Is it greater than 0.1? Is it greater than 0.01? Like you can just look at that p-value and know if it's greater than or not. For the Z, I have to look at the Z, the critical value at that Z to know if it's greater or less than. So it's a little bit harder with that Z score. But all this wants is your Z is equal to 2.23. If I go 3 places out, well, no. Sometimes your teacher should read it right. I don't know where I got that. 2.30. Sometimes when you round 2.296, it's going to bump the 9, which bumps the 2. Okay, there. Or we could have used the formula. Some of you prefer formulas, totally fine, versus StatCrunch. The formula is p hat minus p over the square root of p times q over n. We've already learned a lot of these symbols. So p hat comes from our information that we were given here, which is 0.54. So 0.54 minus 0.5 over our P times our Q is 0.5 times 0.5 over our N of 824. So then we just put that in our calculator. So 0.54 minus 0.5 is 0.04. I'm going to divide that by, I'm going to put that whole thing in my calculator, the square root. Under the square root, I want 0.5 times 0.5 divided by 824 million parentheses later, I get the same exact answer. So do you have a formula? Yes. The formula is not that bad either. None of them are. So if you prefer formulas and you have your formula on your note sheet and you don't have to go to StatCrunch, that's totally acceptable. But I really think StatCrunch makes it a lot easier. So here's our Z statistic. Here's our p-value, okay? So on your homework, most of it will be hypothesis, but a lot of it will be, what's the test statistic? So formula or StatCrunch, it's totally fine. So next one's the same kind of idea. So the mean pulse rate in beats per minute is equal to 69 for a random sample of this many males. The mean is blah, 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 blah. Standard deviation is find the value of the test statistic. So we're doing the test statistic again, but this time it's given of means. So where in stat, I do not want a proportion because I don't have a proportion. I have a mean. What do I use? I use a T of one sample with summary. I don't have data. And then you have to give your sample information here. So our sample mean for random sample, our mean was 69.4. Our sample standard deviation was 11.3. Our sample size was 158. And what would have been our hypothesis test, I should have probably wrote this down, is they claim it's 69 and they claim adult males equal to this, a random sample. Yeah, so we aren't saying it's most or it's not equal. It's going to be a two-tailed test because it just says that they're equal to 69. It doesn't say something like most adults or at least or, like we have seen. So I'm going to push compute, and there is our T statistic for this one. So our T statistic is going to equal 0.44. Okay, and then we see our probability value is high. So we're going to reject that null. Where the other one, it depended on your level, but it was really low. So if it's low, the null must go. So the null was out on the last one. And this one, we're saying it's high, so the null's not going away. That's where we're at with that one. I don't know if I quite said that very well, but we aren't quite to that. But that's where we're headed. I like to show you like what we're headed. You have to be able to come up with this T statistic. Now, I don't remember the formula off the top of my head for the T. Okay, so the formula, if we did this one by hand, would be X bar. So X bar is the sample, so 69.4 minus the 69, all divided by S, standard deviation 11.3, divided by the square root of 158. So that's our formula for that one. I'm going to put that in my calculator. 69.4 minus 69 is 0.4. I'm going to have to do this one in two steps. So 11.3 divided by that square root of my N. Oops, I put that in wrong. Square root of 158. And I get like 0.89 something. So I'm going to do 0.4 divided by my last answer, and I get the 0.44 value. So I can get that test statistic by the formula of X bar, right? X bar from the sample minus the 1 from the population, all divided by the sample from the standard deviation sample, divided by how many people we had in the square root there. Phew. Okay, test statistic. The proportion of people who have died from COVID is 3%. State the type 1 and type 2 errors that would be in context. So type 1 error would be that you reject the null when the null is true. So what would be the null on this one? It would be that you're equal to the 3%, and the alternative would be that you're not equal to 3%. We didn't state like less or greater. It's a two-tailed. So type 1 would say we reject this claim of the 3% of people who have died when actually 3% of people have died. Okay, we reject it, but really that's true. Type 1. Type 2 would be you fail to reject the claim. So I failed to reject this claim when it actually is different from the 3%. So I failed to reject this when it really is this. All right, I didn't write it all the way out, but that's our idea on that one. Okay, so lots of writing your null hypothesis and finding your statistic, and you just go to stats, T if it's a mean, one sample, summary, okay? If it's a proportion, you go to stat, proportion, one sample with summary, okay? All right.